Okay, glad you're back with me. A little bit of review. Okay, y equals mx plus b. Uh, Learn to say that in your sleep. You're going to be um, working with that for like the next 3, 4 years probably. So it's going to be your best friend, and it's a good best friend to have. Anyways, okay, so y and x are just our points. Typically, we're going to leave those as y and x because in a graph, the function has an infinite number of y's and infinite number of x's. So to be able to account for that, we leave them as variables typically. Okay, so m is our slope, b is our y-intercept. So let's go through a few examples just so we know how to work with this. Example here. Look at this here. 3x minus 2y equals 4. Let's convert this into slope-intercept form. This is a function. So ask yourself, what's happening to my y? Because we want y by itself, just like up here. Well, we have multiple terms, so we know we're going to add or subtract. And let's see, a 3x is positive, and it's kind of being added to it. So let's subtract a 3x from both sides. These two 3x's will cancel, so we're left with negative 2y equals negative 3x plus 4. And I put the x in front of the constant just because that's how our form likes it up here. So here we have negative 2y equals negative 3x plus 4. Hope you can see that all right. Okay, what's happening to my y? Ask yourself once again. Well, it's being multiplied by negative 2. And we only have one term, so we know if we only have one term, we multiply or divide. In this case, we're going to divide because that undoes the multiplication. So we divide by a negative 2. Make sure it's a negative 2. Just a 2 wouldn't cancel out the negative sign. So divide both sides by a negative 2. And remember, this negative 2 is dividing both terms in the numerator, since we have more than one term. Both terms in the numerator. So we can split that up and say y equals 3 halves x. The negative and negative turn to a positive. Plus positive 4 divided by negative 2, which is going to end up being a negative 2. And this indeed is in a slope-intercept form. All right, very good. Now let's move on to another example. Okay, so here, here up here we have negative 4x plus y minus 2 equals 0. Okay, so what we're going to do is ask yourself, is this in slope-intercept form? No, not yet. And we remember that slope-intercept form has the y by itself. So let's do that. Let's get y by itself. And in other words, we're saying let's solve for y. Okay, so what's happening to my y? Well, let's see, we have a negative 4x that's being added to it, and also we're subtracting 2 from it. Let's deal with the 4x first. Negative 4x can only be canceled out by adding a 4x to it, so let's do that to both sides. So we're left with y minus 2 equals 4x plus 0, or just 4x. Ask yourself again, what's happening to my y? It's being subtracted by 2. There's two terms here, so we add or subtract. In this case, we're going to add to cancel out our negative 2. Do that to both sides, so y equals 4x plus 2. Are we finished? Yes, indeed. Obviously, you see I didn't write anymore. And also, this is slope-intercept form. Y equals mx plus b. M, the slope is 4. B, the y-intercept is 2. Okay, moving on. Now, another type of question we might see is this. What is the slope-intercept form of a function with a y-intercept of negative 4 and a slope of 1/2? Okay, that it could be confusing. But let's recall, what is slope-intercept form? It's y equals mx plus b. Okay, what is our m? Let's review that. M is our slope, b is our y-intercept. So this is actually pretty easy. We're just substituting the given information into our standard form, a slope-intercept form. So we saw the slope was 1/2. Let's substitute 1/2 for m, 1/2 x. And the y-intercept is negative 4. Let's substitute negative 4 for b, negative 4. So y equals 1/2 x minus 4 is actually our final answer. Now you might be asking yourself, well, we still have a y and x in our function, and we want to keep it that way. This is just slope-intercept form. We aren't trying to find any individual points. So we want y and x to remain variables, because like I mentioned before, like here's our axes, whatever, I don't know. Say this is our function, you know, it goes infinitely in that direction and infinitely in this direction. So y and x can have an infinite number of possibilities. So we leave these as variables to account for that. Moving on, another type of question you may see if we ever have quizzes again. Let's see, what is the slope and y-intercept of this function? Okay, so we're given this right here. Y minus 3 equals 4x. Well, ask yourself, is this in slope-intercept form? It is not. Well, to help us out, why don't we make it slope-intercept form? And once again, we remember it's y equals mx plus b. So let's get it that way. So we want y by itself. What's happening to y? It's being subtracted by 3. Oh, that's more than one term, isn't it? Yes. So let's add or subtract. Let's add a 3. 3 to both sides. These will cancel out. So we're left with y on this side equals 4x plus 3. The original question is, what is the slope and what is the y-intercept of the function? Well, we remember that, okay, slope-intercept form, y equals mx plus b. M is the slope, b is the y-intercept. So m was the coefficient on x, b was the constant at the very end. Coefficient on x is 4, that is our slope. The constant at the very end was 3, that is our y-intercept. Not too bad, huh? Alright, a couple more here and we'll be done. Okay, so it says, graph this line, y plus x equals 2. Y plus x equals 2. Okay, we've never really graphed anything like this before, so this could be a little difficult. But actually it's not. Just think through this. First of all, ask yourself, is this in y-intercept form? Probably not, since I'm asking. So let's make it in y-intercept form. Y plus x equals 2. Let's get y by itself. So let's subtract x from both sides. These x's will cancel out. So we're at y equals negative x plus 2. Remember, keep the negative with the x here. So negative x plus 2. And that is slope-intercept form. So ask yourself, what is my slope here? Negative. And we assume there's a 1 there. So our slope is actually negative 1. What is our y-intercept? Our y-intercept is the constant at the very end. It's 2. Okay, so pretty simple. I already drew this out here. But what you would do is, let's say, okay, let's start with the y-intercept. The y-intercept is where the graph or the function or the line crosses the y-intercept. And it's at 2. So we could start here, 2. And then what is our slope? Negative 1. So what we could do is go a run of positive 1 and then a rise of negative 1. So that's 1 over negative 1, which ends up being a slope of negative 1, if that makes sense. Then we can keep doing that. Run of 1, rise of negative 1. Run of 1, rise of negative 1. And then just connect the dots. Easy as that. Not too bad. Okay, so let's see. So a little bit more. Oh, you don't want to see that yet. This is the last problem. Okay, great. So what is the slope and intercept of this graph above? Okay, so basically this is going to require us to read the graph and then interpret how we have read it. So let's look at this. How could we read this graph? Well, what can we see about it? We could do rise over run for the slope, just like we've done before, right? So we could pick any point here. Let's start at, let's just start on the y-axis. So this point here is 0, 3, right? So that's a good point to start. So we could rise 1 over the run, which is 1, 2. So it was a run of 0 to 1, 1 to 2. And that's at a nice whole number point that we can work with. So our rise was 1, run was 2. Rise over run, our slope is 1/2. Okay, that's good. We have the m, right? Now we need to find that pesky y-intercept. Oh, that's not too hard. We can just see it right here. The y-intercept is at 3. So we have our m, we have our b, and remember, we want to keep our x and y's in the equation. So what we can do is y equals mx plus b. That's slope-intercept form. That's what we want. We said our m, our slope was 1/2. Our y-intercept was 3. So we just substitute that in. Y equals 1/2 x plus 3. Okay, we'll have just a couple more minutes on the next video for your homework, and also examples so you know how to do it.